Agents can't safely use smart contracts until contract interfaces become clear, structured tools. In this module, we'll turn ABIs into readable actions, classify risk, explain functions, and prepare transactions carefully before anything is signed or sent. We've built from agent basics to wallets, signing, payments, authentication, and safety guardrails. Now we move one layer deeper, converting smart contract interfaces into tools agents can inspect, explain, and prepare safely before execution. A smart contract exposes an ABI, its functions, events, and data. But an ABI by itself is not yet an agent capability. Tooling translates it into structured operations the agent can reason about, such as reading state, explaining a function, building a transaction, simulating outcomes, and classifying risk. That safety layer matters because blockchain actions are often irreversible. The goal is not automatic signing. It is informed, constrained action with clear user approval. Think of the ABI as the agent's practical map for a smart contract. It shows which functions exist, what inputs they need, what outputs to expect, and whether a call changes blockchain state. View and pure functions are usually safe reads. Non-payable and payable functions usually require transactions and gas. Events act as signals the agent can watch to understand what happened after execution. Without the ABI, the contract is mostly a black box. Turning an ABI into agent tools is more than a formatting step. First, parse the contract interface and keep only the functions the agent should actually use. Then convert each function into a typed schema with clear parameter names, expected values, and descriptions. Add operational context, such as contract address, chain, mutability, and risk. Only then should the tools be registered, so the agent can call them safely and predictably. A tool schema is the agent's contract for safe action. If a raw ABI name is unclear, wrap it in plain language. Balance of can become read token balance. Make every input explicit, including address format, token ID type, decimal handling, chain ID, deadlines, and recipients. Keep read-only tools separate from transaction preparation tools, so a request for information can never become a write. Finally, define expected outputs and constraints, so results are predictable and auditable. Read tools give the agent a safer way to inspect blockchain state. Instead of sending a transaction, the agent uses an RPC ethics call to ask questions like, what is this balance, who owns this NFT, or how much liquidity is in this pool? The key step is translating raw contract responses into useful values, especially decimals and large integers. Once normalized, that data can support research, portfolio views, DAO checks, and transaction planning. Raw ABI entries still need interpretation. A name like transfer or approve only becomes safe to use when it is backed by context from metadata, verified code, documentation, and token standards. The tool should turn that evidence into a plain language explanation: what the function does, what inputs it needs, what it may return, and what state or assets it can affect. If behavior is inferred rather than verified, the agent should say so and flag risky actions before execution. Every contract function needs a risk label before the agent uses it. Read-only calls can usually run automatically because they do not change state. Low-risk writes may be allowed with clear user confirmation. High-risk writes, such as moving funds, minting, borrowing, or changing positions, should be simulated first and explained carefully. Special cases like approvals, admin actions, payable calls, transfers, and unknown functions need the strictest defaults: limit, warn, or block. Risk classification starts with the cheapest signals. State mutability tells you whether a call is likely read-only, payable, or state-changing. Function names add clues. Approve, transfer, mint, burn, withdraw, borrow, and upgrade often point to higher risk behavior. Parameters add more context, especially spender, recipient, amount, operator, deadline, and to. Finally, compare the function against known standards like ERC20 or NFTs. If the pattern is unfamiliar, label it unknown until source review or simulation confirms intent. For write operations, the agent's role is preparation, not custody. It builds an unsigned transaction from the selected contract, ABI, function, and arguments, then adds chain ID, sender, value, nonce, and gas strategy. Before anything reaches a wallet, it validates arguments and runs pre-flight risk checks. The user then sees a plain language summary and explicitly approves or rejects. Private keys never enter the agent layer. Signing stays inside the wallet. A good pre-flight catches common failures early. Confirm the wallet has enough native token for gas and for any payable value. Verify the ERC20 balance for the requested action. Check allowance, because many transactions fail when the spender has not been approved. Then estimate gas. If fees look abnormal or funds are short, stop, explain the issue, and recommend the fix. Simulation adds another layer of protection before signing. The agent can test the transaction with a call or a simulation service. If it fails, revert data becomes diagnostic evidence. With the ABI, the agent can decode errors like insufficient allowance, slippage, an expired deadline, a paused contract, or an unauthorized caller. Then it can recommend the safest fix, such as approving USDC first. A successful simulation reduces risk, but it is not a guarantee, because blockchain state can change. In production, reasoning should never connect directly to contract execution. Put a safety layer in between. The tool registry limits which contracts and functions are available. A risk classifier applies allow lists, deny lists, and protocol policies. Pre-flight checks and simulation inspect arguments and expected effects. Risky writes, approvals, transfers, payable calls, and admin actions require explicit user confirmation. The tool prepares and explains the transaction. The wallet alone signs and broadcasts it, with every step logged. The big idea is simple. Agents need guardrails before they touch contracts. ABIs become usable tools, functions are explained and classified by risk, and pre-flight simulation catches problems early. That foundation turns agents into safer collaborators for DeFi research, swaps, governance, NFTs, and broader on-chain workflows.